Okay, now, so we have finished talking about addition polymerization, whereby we are dealing with alkenes monomers. Now, the second type of polymerization is known as condensation polymerization. Now, when you see the word condensation polymerization, it means that condensation will produce small molecules such as water. Now, I have listed two examples here, A and B. Now, let's look at A first. Now, for A, on the screen here, you actually see a diol and a dicarboxylic acid. Now, diol means it is a molecule that has two alcohol functional group, right? Similarly, for dicarboxylic acid, it's a molecule with two carboxylic acid functional group, COOH here and COOH here. Now, so as you have learned esterification, when you have an alcohol and a carboxylic acid functional group together, right, esterification can happen, right? So if you recall back, when the acid and the alcohol react, it is the OH from the acid and the H of the alcohol, they will be eliminated to form H2O. Now, so this O now, this particular O now, will now join to this C. Because as you can see now, this C is missing one bond after this OH has left. This C needs to bond with something else. Same goes for your O. So these two parts, they can join together. So this is the new bond formed. Now imagine to this side here, the OH can also be removed to form water molecules with another diol over here, right? Similarly, this diol, this hydrogen here, can also be removed to form another bond with another dicarboxylic acid. So therefore, over here, we put a bond here. Over here, we will put a bond here to indicate that there is a molecule, or the structure continues from here, the structure continues from here. So as you can see from this diagram on top here, where is the link that is linking these two molecules together? It is this part here, right? This is the new bond that has been formed between this oxygen and this carbon. So this oxygen is this oxygen, this carbon is this carbon. So they come together to form this bond, the CO bond here, right? Similarly, over here, so this OH also removed, this H removed, they continue to form ester linkage. Now this is what we call ester linkage, because this is exactly how an ester is formed. An ester is formed when the acid functional group, the OH of the acid, and the H from the alcohol eliminated, and they bond together to form this bond here. So if I have many dicarboxylic acids, I have many diols, okay, it will go on and on and on because of the two ends. They can continue to react. Now, what you have seen here, this is just one repeating unit. This is one repeating unit. Okay? If the question says show two repeating units, you will have to repeat this whole thing. You will have to draw this whole thing twice. One more time here. This is one repeating unit. This one repeating unit is made up of the diol, this part here, and the dicarboxylic acid here. Okay? Now, some of you may be wondering, what are these boxes. Now these boxes just represent the hydrocarbon chain because we don't know how many carbons are inside here. It can be CH3, it can be CH2, 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 it can be CH2, CH2, can be just CH2. So since we don't know how big this middle carbon chain is, we just put a box to represent. Because what is in the middle will not affect the reaction. It is the two sides here that will form the ester linkages. Now, so what you have seen above here, this is called the ester linkage. Now, what is below now is the second type of condensation polymerization. Now, it is very similar to the ester linkage. The only difference is instead of a diol, you now have a diamine. Now, if you compare this and this, okay, instead of OH, you now have NH2, okay, which is called an amine functional group. But the theory is exactly the same, right? The OH from the carboxylic acid will react with the H from the diamine. So this will be eliminated to form a water molecule as well. So as you can see, this is still a dicarboxylic acid. But now instead of diol, you have diamine. But similarly, both of them will remove water molecule. So if I were to remove away this water molecule, what is left behind is almost the same. Now this bond here will bond to this C. Right, as you can see now, the new bond formed is here. Where does this bond come from? When this H and this OH has been removed, this N, this particular N, and this C, now both of them needs to form a new bond. This C and this N, now they need to form a new bond. That's why the C and this N will now come together and form this bond. Now this bond is called an amide linkage. The one above is called ester linkage, C double bond O. Right? Amide linkage is referring to C double bond O and H. This is the amide linkage. So similarly, this thing here that I have drawn is just one repeating unit. Regardless whether it's an ester linkage or is it an amide linkage, just like any other polymers that we have shown so far, the two ends of the polymer, you must show me the bonds here, 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 and here, to show that this polymer is continuous, is continuing, right? It does not terminate here. All right, so this is amide linkage, ester linkage. Ester linkage is when you have a diol. Amide linkage is when you have a diamine with two H and one nitrogen. But similarly, both of them remove water molecule.